Assalamualaikum and good morning. Today, our groups will present the project that our group choose, which is flood detection system. So this is our group members, which is the leader ISYRAF bin Shahrulizan. The members HARISH, RAGGAVENDRA, as DIVANESH, and myself WEJAYA bin Azhari. So the introduction of this project: IoT early flood detection and avoidance system is an intelligent system that keeps close watch over various natural factors to predict a flood, so we can embrace ourselves caution to minimize the damage caused by the flood. Natural disaster like flood can be devastating, leading to property damage and loss of life. To eliminate or lessen the impact of floods, the system uses various natural factors to detect flood. The system has Wi-Fi connectivity, thus the collected data can be accessed from anywhere quite easily using IoT. The purpose of this project is to detect a flood. The system observes various natural factors, which include humidity, temperature, water level, and low level. To collect data on mentioned natural factors, the system consists of different sensors which collect data for individual parameters. For detecting changes in humidity and temperature, the system has a DHT11 digital temperature humidity sensor. It is an advanced sensor module which consists of resistive humidity and temperature detection components. The water level is always under observation by a float sensor, which works by opening and closing circuit as water level rise and fall. It normally rests in the closed position, meaning the circuit is incomplete and no electricity is passing through the wires yet. Once the water level drops below a predetermined point, the circuit completes itself and sends electricity through the completed circuit to trigger an alarm. The flow sensor on the system keeps eye on the flow of water. The water flow sensor consists of a plastic valve body, a water rotor, and a Hall effect sensor. When water flows through the rotor rolls, its speed changes with different rate of flow. So that is introduction of our project. I will pass to Harish to tell about the requirement.
Okay, madam. My name is Harish. Okay. For this project, there are some requirements that we need so that we can finish this project. Okay. First of all, the water level sensor will be set at 2 points of water level, which is at 0.05 meter and 0.09 meter, which we set. When the water reaches this point, it will light on the LED and trigger the buzzer that acts as an alarm to alert both authority and the owner. All the readings of water level are shown in an application called Blink that we connect through the connection of a Wi-Fi for reference. This project applied both hardware and also software programming. The hardware components of this system is divided into 3 main parts, which are the water level sensor as the input system, and Arduino Mega 2560 as the main microphone. Finally, also an ESP8266 Wi-Fi module as an interface with the output and connection application respectively, and LED and a buzzer as the output system as usual. Meanwhile, for software programming, Arduino software IDE is used for hardware coding. Okay, that's all for me. That's all the requirement. Okay, next, I will pass it to DIVANESH to continue this presentation.
My name is DIVANESH. Now I'm going to present about the methodology. So first, we're going to start and initialize the port, and we got a sensor which is called ultrasonic sensor, and the LED 0.05 amp. It will be when the water rises to 0.05 amp. The authority will get notified through the IoT application, a green light will light on the buzzer, will notify and also beep. So when it's LED in 0.09 meter, so it is the second level, which is denoted as laser, and it also will beep. The system will trigger both outputs simultaneously. So this both will trigger and make the buzzer to beep, and then it will send the data to server. If success, it monitor the application. If not, it will back to the initialized port. So that's the end of the flowchart. So I'm now going to show the block diagram. So for this, it's an input ultrasonic sensor, and we'll go to the process at mega 2560 and go to the green LED. Buzzer will trigger at 0.05 amp, and red LED and buzzer will trigger at 0.09 amp, and go to the application. From the process at mega 250, we'll go to the server, and the server will send to the application. So now I'm going to explain about the step of the project. The flowchart of this flood level monitoring system is integrated with the ultrasonic sensor. The flowchart presents flood level sensors placed at certain heights. In this case, 0.05 amp and 0.09 amp. When the water rises to 0.05 amp, the authority will get notified through the application, to the IoT application. A green LED will light on and the buzzer will also beep. The water level will be displayed on the LCD screen as shown in figure 5. As the water reaches the second level, which is denoted as the danger stage, that is 0.09 amp. The authority will get also notified, but with a slightly different notification, where the system will trigger both outputs simultaneously, which are red LED and buzzer, but with different sounds compared to the first level. The authority will then alert all users could affect and ruins any part of the vehicle, especially the engine system. In a nutshell, the system is not only limited to monitoring water levels in a flash flood, but also is capable of notifying certain individuals. And that's all from me. So now I'm going to pass to IZZAT.
Thank you, Divanesh. I'm here to continue to explain about results and discussion. Okay. The simulation for this system is constructed and simulated by using Proteus Professional 8 software. To simulate the circuit, first the library of the software must be added to the Arduino library. After that, the simulation can be done by picking all the components, and the script for the circuit was loaded to the Arduino board in the Proteus. The figure below shows the simulation in the water level sensor without connecting to the Arduino board to get the voltage and current for each leg. It used 5 voltage operating powers. Figures 7 to 9 show the measurement results of this flood warning system. The result was shown in 3 methods: LCDs, the lighting of 2 LEDs, and message notification that have been sent to the user's phone. The LCD is used to display the water level reading of the flood. When the water level reaches the danger stage, the red LED will be light on and the message will be sent directly and wirelessly using the Blink application as shown in figure 8. The Blink application can be installed by the user in their mobile phone via Android operating system or iOS operating system. Next. The type of sensor was defined as an ultrasonic sensor. The specification referred for the sensor to operate was using the datasheets. The datasheet for another component was referred to acknowledge the behavior and characteristics of the component. The connection of the controller at Mega 2560 was drawn and the number of pins to connect is set. At Mega 2560 supplies 5 volt voltage to the ultrasonic sensor, with a voltage divider supplying 3.3 volt to a Bluetooth module. When the ultrasonic sensor detects the level of water, it will trigger the buzzer and will light on 2 LEDs in green accordingly. The LEDs are constructed in parallel and each LED represents the stage water level, where green where green is the first stage and the red as the third stage, which is the danger stage. Coding to operate the component was created using the Arduino IDE. An equation to measure the level of the water in the tank was created. The last part of this system is to send the data or notification to the user's smartphone through the Blink application that was installed. IoT technology is implemented in this part by using the ESP8266 Wi-Fi module board. Next. So at the left is the two green LED, and red is which is the danger stage LED. So at the left side is the circuit for the flood detection system, and the right side is the notification, which is to alert the users to notify they are in flood through the Blink application. Next. So what is the advantages and disadvantages for this flood detection system? For advantages, based on flood issue in Malaysia, we need a flood monitoring system for people to take action earlier before the flood coming. Second, to save citizens money. And third, which is to make sure we have early warning to save a life. Next, can save government facilities and house furniture. Move on. The disadvantages of flood monitoring system is we need a consistent maintenance to ensure its efficiency. Second, it very high cost to put the system around Malaysia. Okay, I'm settled about my part. I'm gonna pass it to ILHAM WEJAYA. That's all from me. Thank you.
Thank you, IZZAT. So, as the conclusion from this project, students are able to design and creating IoT project based on upcoming technology that transforms the everyday object into an ecosystem that will enrich our lives and make it simpler. Other than that, this project enable the students to understand a little more about how does the IoT cloud which works, which is the transfer of data onto the cloud for storage and analysis with ease. In addition, this project are also encouraging students to know more about the Internet of Things technology, so that more creative invention that will help people to be better in their life and in the future too. So we can conclude from this project, which is bring many benefit to us when handling some natural disaster such as flood. People can be more prepared from the disaster that would be happen to them if they implemented this project more efficient and widely to people out there, so that people can know about it and get to know the awareness. So that's all from our group presentation. Thank you.
So this is the video reference, so Madam can look through it. So that's all